A.CED.4. This is creating equations that describe numbers or relationships. And today we're going to be rearranging formulas to highlight a quantity of interest using the same reasoning as in solving equations. So we've done a lot of solving equations, and today we are just going to be isolating a particular variable dependent upon what the problem asks for. So which variable are we going to solve for? We have one term to know. It is a literal equation, so please pause the video and get that defined in your journals. Here is a pretty popular equation. It's the formula for the area of a triangle. A represents area, the B is the base of the triangle, and H is the height. And according to the directions, it wants us to isolate or solve the equation for B. So B is going to be the quantity of interest here. And in order to do that, we're going to think back to our solving equation rules called the inverse operations. And you notice that the 1/2 and the H are both touching the B on both sides. So that means there's multiplication going on. So in order to undo that, we're going to use our inverse operations of multiplying by 1/2. So what was that? What did we have to do to get rid of the 1/2? All right, in order to do that, we had to multiply both sides by the reciprocal of 1/2. So that would be 2 multiplied by A, we could put it over 1 as a fraction. It doesn't change the value. And then we take the 2 and multiply it by our 1/2, and then we have our B and our H. I guess we could quantify that separately. All right, so working from left to right, 2 multiplied by A over 1 would be just plain 2A is equal to cancellations. We just have our BH left. Okay, we're almost there. That was our first step. Now we do step 2. If we're solving for B, that is the quantity of interest, we have to do the opposite of multiplying, which is dividing by H. So divide both sides by H, and B is equal to whatever 2 times the area that they give us divided by the height which they give us. Again, we're assuming that the problem states what the area is given and what the height is given, and we have to take that quantity, put it all together, do the math, and figure out the base of that particular triangle. This is working literal equations. All right, here's another popular formula. It's called the distance formula, where D equals RT. D is the distance, R is the rate of speed, and T is the time that it takes. So on the left side, it looks like we want to solve the equation for R. So that means we need to get R by itself. Well, it is touching the T, so the inverse operation would have to be division on both sides. And if we're solving for R, we want to get rid of the T. So T cancels out, and R, the rate, is equal to whatever the distance they tell us divided by the time that they give us. And that will tell you your rate of speed. Over here on the right, it looks like they want us to solve the equation for T. So we start with the same equation. T is the quantity of interest. So in order to get rid of the R, again, we divide both sides. So the time that it takes will be equal to whatever the distance given divided by the rate of speed that is also given. That will tell you the time that it will take, T. All right, so here I gave an example where it says solve for X in the equation. So in both equations, we need to isolate X and get it by itself. Well, what I did is I put some numbers on the left-hand problem here. I put some numbers in there because I want you to realize that we've already done this. We've spent a lot of time solving equations. This is a two-step equation. And we would do all the inverse operations and find out what x is. Well, on the right side, all I did was I replaced my 4 with an A, my 6 with a B, and my 13 with a C. The one on the right is the literal equation, so it's just manipulating the equation and moving things around. And I don't want you to be afraid of the one on the right because you already know how to do this one from the left. It's just got numbers inputted inside of it. So let's work out both of them and see what x is going to equal. Subtract 6 from both sides. So this gets you 0. All right, last thing. Dividing by 4, the inverse is multiplying by 4. So x should be equal to 4 times 7, which is 28. So we've solved for x. X is 28. So when I take 28, I could substitute it for x. 28 divided by 4 is 7. 7 added to 6 is equal to 13, so it checks out. Now on the right side, again, what you're doing is you're practicing a lot in this section 3.8 by solving literal equations. So how are you going to get to the x? Well, you do the inverse operations like you did on the left side. Subtract b from both sides. Oh, I forgot to do that. Got to put it in here. So x over a plus b minus b. All right, now we go. So x over a is equal to, this is gone, c minus b. We don't know what the numbers are, and right now it doesn't matter to us. We're just moving the equation around. And what would you do here to get x by itself? Multiply both sides by a. So we say x is equal to a times the quantity of c minus b. Now it's important to know that since we are unaware of what c and b are in terms of values, we do know that when you put them together, you're going to get some type of integer. So when you multiply both sides by a, understand that you're not just multiplying a times c and then subtracting b. You're multiplying a times whatever this whole value is. So c minus b is an entire quantity. So x is equal to a times the quantity of c minus b. If you have any questions on that part, make sure you see me. Okay, the next one is rewriting the equation so that f is a function of c. Right now, the way that it is written, it's saying that c is a function of f. Is means equals. So if you see the letter f and then the word is afterwards, what they want you to do is they want you to solve for that given variable. So f is the quantity of interest that we're looking for. So we're going to have to do some rearranging of this equation. You know what? Why don't you pause the video right here and try to work this out. Try to get all of those terms away from the f and see what that's going to equal. Pause the video and give it a try. Okay, we're back. So I see that 5/9 is multiplied by a quantity, so that when I undo that, I multiply both sides by the reciprocal. We've learned that. So 9 over 5 times c over 1 is equal to all right, now what happens? So we have 9/5 times c over 1 is still 9/5 times c. These all cancel, and we have f minus 32. All right, we still need f to be isolated, and we have a negative 32 with it. So we need to add 32 to both sides. Now, I didn't show the work on adding 32 to the negative 32, but we've done that enough in class to know that we're still doing the inverse operations to isolate F. So if you're calculating between temperatures in Celsius and Fahrenheit degrees, this formula can be manipulated both ways. So you'll get Celsius equaling your Fahrenheit values or your Fahrenheit values equaling your Celsius, and it's basically just a little conversion formula that's used. And that's actually an example from your textbook. They have some worked out solutions in there. You'll want to take a look at that. That's section 3.8 in our current book. Okay, in your journal, I'd like you to define that term that we were talking about, literal equation. And if you have any questions from the video, please ask me, bring your questions to class so that we can discuss it with your students. They might have the same questions as you do.